Assalamu alaikum. Now this is the second type of organic reaction. This is not related to addition reactions at all. This is a whole separate category. Substitution reactions. And the first thing that I'll say about these is that they are a lot slower. Okay, and always require catalysts. So something that helps speed it up. In some cases, it's usually, the catalyst is like light, UV light specifically. And even then, it doesn't fully react all the way. And the reason why they're slower is because alkanes and benzenes, are stable and hard to react with. And so there's a general form for this reaction here. So again, the alkanes and benzenes are stable and it's hard to react with, so they go very slow. The general form that this takes place is an alkane or a benzene, okay, plus a halogen, and sometimes in the textbook they call these halides, okay, gives you a haloalkane, so an alkane with a halogen on it, or benzene, okay, plus a hydrogen halide. Now, sometimes this reaction confuses people because they said, well, benzenes have double bonds, so aren't they alkenes? Remember that double bond in the benzene keeps rotating in a circle, so it's not actually staying put, so it's not a real permanent double bond. So this is the general form for your substitution reactions. Alkane or a benzene plus a halogen gives you a haloalkane / benzene plus a hydrogen halide. Let's look at an example and see how this transpires. And so here we have 1, 2, 3, 4. We have a butane plus chlorine gas. What happens here is the chlorine gas is Cl to Cl. And when we look at the general form, there's still one of the halides left. So the difference between the addition reactions and the substitution reactions is that only one reacts. We're going to write only one reacts. And so what we end up with, now when it reacts and it bonds, it actually, in the process, a H is substituted. Then that's why we call it substitution, because it's substituted with your chlorine. And so on the other side of the molecule, and I'll do it here, we end up with, as our general form suggests, we got a haloalkane plus what is the hydrogen halide going to be? Well, when that hydrogen gets substituted, it in turn is going to bond with the leftover chlorine. And so we're going to have HCl. Sorry, let me try and make that a little bit smaller so I can fit it in. Right, so here's our haloalkane. This is 1-chlorobutane. And then this is hydrogen chloride. Okay, and this would be a gas. Let's look at another example. Okay, now in our last example, we forgot that this needs UV light. Okay, so which is sunlight. And so the same thing is going to happen here as it did in the previous example. only one of these is going to react, and it could go to any one of these. That is not the important thing. And when it lodges itself into the carbon, a hydrogen gets launched out. And that hydrogen is going to bond with the leftover Br. So when we start to draw our products, over here we still have a benzene, but now we have a bromine attached to it. And it's going to be plus a hydrogen bromide. Okay, and the name for this one, so we went from benzene, okay, to 1-bromobenzene. All right, let's look at one more example. Now in our third example here, I tried to do it a little bit different. We got the catalyst, we didn't forget this. Here is our halogen, right? It's fluorine. And so that's a fluorine to a fluorine. Now, here's the difference. There's already a fluorine on here, but that actually doesn't do a thing. The fact that this here, okay, is an alkane means that it can only go through a substitution reaction regardless of whatever else is bonded to it. And so, just like our others, one of the fluorines is going to bond itself to the carbon, which will release, okay, a hydrogen, and that hydrogen is going to bond itself to the remaining fluorine, and so we end up getting a more halogenated alkane. So right now we had 2-fluoro 1, 2, 3, 4, 5 pentane, and it will turn into we got fluorine that's already there. We got a new fluorine that is present over here, plus HF, which is hydrogen fluoride. And so no bonds were broken. The hydrogen was substituted once again, and the initial reactant was an alkane, and so this still qualifies as a substitution reaction. And this would be 1,2-difluoropentane. That is it for substitution reactions. Re-watch this video, try it out yourself without looking back to the video for answers, and of course do the practice worksheets. Assalamu alaikum.